Is Anycubic's newly launched 3D printer, the Kobra X, that includes their new multi-material filament system, a better value than Bambu Lab's A1 combo? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations, and welcome to today's video to take a peek under the hood of the newly launched Anycubic Kobra X 3D printer and compare it to the Bambu Lab A1 combo printer. No, you're not seeing double. The Kobra X and the A1 look very similar, but they also have several major differences. I'll cover initial prints, features, unboxing, cost, and my final summary of both printers so you can make an informed decision on which model 3D printer you may want to consider buying. I've organized the video into chapters listed in the description that will allow you to skip around the video depending on what's important to you. I bought the Bambu Lab A1 combo with my own money. However, I want to thank Anycubic for sending me the Kobra X for my evaluation. Okay, let's get started. Let's first start with the most important part of evaluating a 3D printer, and that's the quality of the parts. I printed parts using PLA, PETG, TPU, and a TPU/PLA combined part that I think you're going to be surprised at the results. First, I printed a preloaded design of a benchy in PLA on both printers. For the A1, the benchy turned out overall very nice, as expected. For the Kobra X, the benchy also turned out similar to the A1. Next, I printed this calibration test designed by Gabox 3D on printables using PLA. For the Kobra X, the overhang test successfully printed all the way to 80 degrees, and overall, it looked good. The various cylinder diameters measured 9.89 millimeters, 7.86 millimeters, 5.71 millimeters, and 4.05 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.06 millimeters, 20.02 millimeters, and 30.08 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were only a few stringers on the Kobra X part. For the A1, the overhang test also successfully printed all the way to 80 degrees. The various cylinder diameters measured 9.72 millimeters, 7.85 millimeters, 5.74 millimeters, and 3.75 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.01 millimeters, 19.95 millimeters, and 29.97 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were little to no stringers on the A1 part. The calibration test results were similar for both printers. Do you remember telling me about a product you designed, but you didn't have a 3D printer to make it? Well, let's go upstairs to grab a drink of water and talk about it. Here's your water. I have a way for you to get your product design made even if you don't have a 3D printer. The sponsor of today's video, PCBWay, is your solution. You can go to PCBWay's website, upload your STL file, and they can make it and ship it right to your door. If your project needs other parts made, PCBWay can also provide PCBs and PCB assemblies, CNC machining, sheet metal fabrication, including bending and laser cutting, and injection molding. PCBWay has a major commitment to quality. They have high quality standards in all of their processes, and they focus on pre-production document checks, ensure high quality raw materials, use the world's leading production equipment, implement in-process quality control, and maintain final quality inspection before each shipment. There is a link in the description below, and they will even provide you with a $5 welcome bonus. Thank you, PCBWay, for sponsoring today's video. Now, let's head back down to the workshop. Next, I printed a spiral vase design using PETG that was uploaded to printables by Max413049. However, the original design is by Big Bad Bison on Thingiverse.com. For the A1, I used basic PETG, and the vase turned out well. For the Kobra X, I used translucent PETG, so it's not an exact comparison, but I really wanted to see how the translucent PETG turned out. I think it turned out beautiful. It appears that both printers can handle PETG without any problem. Next, I printed this truck tire out of TPU designed by Elmcom 193290 on printables. Since TPU can be stringy, I dried this spool of TPU in my Sunlu filament dryer at 55 degrees C for 6 hours. For both the A1 and the Kobra X, the TPU truck tires turned out great. There was a bit more stringing on the Kobra X part, but overall they were of the same high quality. Even though I'm not a big fan of multicolor printing due to the amount of wasted filament and how slow the prints take, it was critical to me to test the new technology of the Kobra X and see what its impact would have to reduce the amount of filament waste and possibly reduce print times versus the A1 printer. The Kobra X has a unique tool head that has all 4 filaments loaded, similar to the A1, but the Kobra X has a lower filament cutter, so in theory there should be less waste and faster print times. But let's test that on a real print. I printed this articulated Rexagon, which is a Trex plus Dragon, Flexi by Pinky Wings on MakerWorld in 3 colors of PLA. The A1 took 6 hours and 13 minutes to print the Rexagon, and it generated 74 grams of waste. The Kobra X took 4 hours and 5 minutes to print the Rexagon, and it generated 62 grams of waste. That means the Kobra X took 2.1 hours less than the A1, or 34% less time. Also, the Kobra X created 12 less grams of filament waste than the A1, or a 16% in reduced waste. I studied the slicer settings for both the printers, and I attempted to make them identical, so I'm surprised at this initial result for both the reduced time and the reduced filament waste for the Kobra X. So far, I haven't found any significant differences in the slicer settings. Both printers produced a high-quality 3-color PLA print. Next, I decided to print a 4-color print in PLA of the Dilophosaurus designed by the Dragon's Den on MakerWorld. The A1 took 21 hours and 37 minutes to print the Dilophosaurus, and it created 301 grams of waste. The Kobra X took 15 hours and 55 minutes to print the Dilophosaurus, and it created 269 grams of waste. That means the Kobra X took 5.7 hours less than the A1, or a 26% time savings. Also, the Kobra X created 32 less grams of filament waste than the A1, or a 10.6% in reduced waste. Both printers produced a high-quality 3-color PLA print. Now let's try to print a part that uses TPU and PLA. Here's a key advantage of the Kobra X versus the Bambu Lab A1. Because the Kobra X is able to print TPU and PLA at the same time, but the A1 can't print TPU with their AMS light unit. I struggled to find a part that was a mixture of TPU and PLA because there aren't that many printers out there that can print TPU and PLA together. I found this TPU plus PLA doorstop design by SD3D on MakerWorld, so I tried to print that. I had to manually paint the design in Anycubic Studio so that the PLA was assigned to the internal structure and the TPU was assigned to the outer shell. The print took about 7 hours to print, and although there was a lot of stringing, I was really happy with the print because this was my first time I ever was able to print TPU and PLA in the same part. So to summarize the parts quality section of this video, based on my experience, the Anycubic Kobra X produced similar high quality prints that rival the quality of prints I produced from my Bambu Lab A1 printer, but in less time and with slightly less waste produced. Now let's cover the main features and the differences between the Kobra X versus the Bambu Lab A1 combo. The Kobra X has overall printer dimensions of 460 millimeters wide by 460 millimeters deep by 690 millimeters high, while the Bambu Lab A1 combo has overall dimensions of 680 millimeters wide by 410 millimeters deep by 620 millimeters high. The reason for the larger footprint of the A1 is due to the AMS Lite needing to be next to the A1, which takes up a lot of space on your workbench. There is an upgrade available to mount the AMS Lite to the top of the A1, but I'm focusing on the out-of-box experience with both printers. The A1 weighs 8.3 kilograms and the AMS Lite weighs 1.6 kilograms for a total of 9.9 kilograms, while the Kobra X weighs 13 kilograms. The A1 print volume is 256 by 256 by 256 millimeters. However, the Kobra X print volume is slightly larger at 260 millimeters by 260 millimeters by 260 millimeters. They are both bed slingers with an open design. Both printers have a maximum hot end temperature of 300 degrees C and a maximum build plate temperature of 100 degrees C. The A1 has a maximum speed of 500 millimeters per second, while the Kobra X has a maximum speed of 600 millimeters per second. And the A1 has a maximum acceleration of 10,000 millimeters per second squared. However, the Kobra X has a maximum acceleration of 20,000 millimeters per second squared. Both printers offer quick change nozzle swaps in 0.4 millimeters diameter nozzles as standard. However, Bambu Lab offers 0.2 millimeters, 0.6 millimeters, and 0.8 millimeter options, while Anycubic offers 0.25 millimeters, 0.6 millimeters, and 0.8 millimeters hardened steel nozzles. An interesting feature of the Kobra X tool head is that the filament cutter is very low within the tool head, which helps reduce the amount of purging of the nozzle when changing colors, and the location of the filaments within the tool head reduces the time between color changes. I did an experiment where I measured the time that it took to change one color change from black to white on both the A1 and the Kobra X, and here are my results. The A1 took 2 minutes and 16 seconds, while the Kobra X took 1 minute and 31 seconds. The Kobra X took 33% less time to switch colors versus the A1. They both have a nozzle wipe feature. Both the A1 and the Kobra X have multicolor filament multi-material capability. The A1 needs the AMS Lite, which offers 4 colors printing. However, you can connect up to 4 AMS units, which will allow up to 16 colors. The Kobra X has a unique toolhead design that can print 4 colors by itself, but you can connect up to 4 Ace 2 Pro units that will allow up to 19 colors. Another advantage of the Kobra X is that you can print TPU and PLA on the same print using the existing toolhead. Both printers can recognize the RFID tags in their filament spools that allow their printers to recognize the color and specific material of each spool. The Kobra X has an RFID reader in the left corner of the printer that can read Anycubic filaments. So when you scan the filament, the Kobra X will automatically assign the material and color to the next time you load the filament onto the Kobra X. I assume the Ace 2 Pro units will have the same RFID reader feature that will automatically identify the Anycubic spools. The Bambu Lab AMS Lite cannot be used with TPU, but the Kobra X can print TPU with the unique toolhead. They both come with double-sided textured PEI build plates. Bambu Lab offers their Bambu Studio Slicer, while Anycubic offers their Anycubic Slicer, and they both offer their versions of phone apps to control their printers remotely. Both printers offer flow calibration and filament tangle detection. They both can print wirelessly using their slicers. They both have auto bed leveling, Z-axis offset, power loss recovery, and an external LED light. You can print the following filaments on both printers: PLA, PETG, TPU, and PVA. The Kobra X can also print PLA CF and PETG CF. Both printers have a 3.5-inch color touchscreen to interface with the printer. You can transfer files using a USB drive for the Kobra X and a micro SD card for the A1. They both have built-in cameras. However, the A1 has a low frame rate camera, so live feed is a bit erratic to watch, while the Kobra X has a higher frame rate camera that has a smoother operation. Also, the Kobra X uses the camera for AI detection. However, the A1 does not have this feature. Now, let's talk about unboxing and setup. It's very similar to unbox and set up both printers, but for this video, I'm going to focus on the Kobra X since it's brand new. Once you remove the Kobra X from the box, it's just a matter of removing the various foam packaging from the printer. First, remove the PEI build plate. Next, remove the toolkit, power cord, filament holder arms, main vertical frame, spool holders, waste flipper, and main base unit. Cut the main base cable ties and remove the foam. Attach the vertical frame to the base with 8 screws. Install the 2 protective covers. Cut the cable ties on the tool head. Remove the 2 packaging brackets that secure the Z-axis. Attach the electrical cable on the main base bottom. Attach the waste flipper. Insert the PTFE tubing into the tool head. Install the PEI build plate. Install the filament spool arms. Install the power cord. Turn on the printer. Follow the screen prompts by choosing a language and follow the instructions. The printer will perform a self-inspection and then input shaping and auto bed leveling. Load some filament into the Kobra X. I also uploaded Anycubic's latest slicer software on my computer. Finally, I was ready to print my first print. Now, let's compare the cost of the Bambu A1 combo and the Anycubic X. At the making of this video, January 2026, the Kobra X Early Bird Special is $279 from January 15th through February 28th. They have another special of $299 from March 1st to March 31st. And then the normal price will be $399 after March 31st. As a comparison, the Bambu Lab A1 combo with the AMS Lite is on sale for $399, normally $559. After the Anycubic special pricing through March 2026, the Kobra X will have the same price as the sale price of the Bambu Lab A1 combo. Now let's go to my final summary. Overall, I'm impressed with the quality of the prints I made on both the Anycubic Kobra X and the Bambu Lab A1 printers. For a variety of materials such as PLA, TPU, and PETG, I consider the print quality to be comparable in quality. I'm especially impressed that I can print TPU and PLA in the same part from the Kobra X. That's not possible with the Bambu Lab A1. The Kobra X has an overall smaller footprint than the A1 due to its unique toolhead design that eliminates the need for a separate filament management module, while the A1 requires the AMS Lite in order to produce multiple color prints. With that said, Anycubic offers their separate ACE2 Pro filament management modules that allow you to print up to 19 colors, while Bambu Lab offers their separate AMS2 Pro filament management modules that allow you to print up to 16 colors. The A1 print volume is 256 millimeters cubed, however the Kobra X print volume is slightly larger at 260 millimeters cubed. One of the most significant features of the Kobra X is that it has a unique tool head that has all 4 filaments loaded, similar to the A1. But the Kobra X has a lower filament cutter, so the filaments have less distance to travel to the nozzle tip. My initial test results are that the Kobra X takes between 26 to 34% less time to print the same part as the A1, and the Kobra X produces between 11% and 16% less waste than the A1. Both printers have a maximum hot end temperature of 300 degrees C and a maximum build plate temperature of 100 degrees C. The A1 has a maximum speed of 500 millimeters per second, while the Kobra X has a maximum speed of 600 millimeters per second. And the A1 has a maximum acceleration of 10,000 millimeters per second squared. However, the Kobra X has a maximum acceleration of 20,000 millimeters per second squared. Both printers offer quick change nozzle swaps in 0.4 millimeter diameter nozzles as standard. However, the Bambu Lab offers 0.2, 0.6, and 0.8 millimeter options, while Anycubic offers for 0.25, 0.6, and 0.8 millimeter hardened steel nozzles. Both printers can recognize the RFID tags in their filament spools that allow their printers to recognize the color and specific material of each spool. Both printers have their own slicer software and phone apps to control their printers remotely. Both printers offer flow calibration and filament tangle detection. They both have auto bed leveling, Z-axis offset, power loss recovery, and an external LED light. You can print the following filaments on both printers: PLA, PETG, TPU, and PVA. The Kobra X can also print PLA CF and PETG CF. Both printers have a 3.5-inch color touchscreen to interface with the printer. They both have built-in cameras, however the A1 has a low frame rate camera, so live feed is a bit erratic to watch, while the Kobra X has a higher frame rate camera that has a smoother operation. Also, the Kobra X uses the camera for AI detection, however the A1 does not have this feature. After March 31st of this year, the Kobra X is going to cost $399, which is the same as the sale price of the A1 combo printer. Although we don't know what the reliability will be of the Kobra X, key features of the Kobra X make it a very attractive alternative to the Bambu Lab A1 combo printer. What do you think? Which of these printers would you buy between the Kobra X and the Bambu Lab A1 combo? Let me know in the comments below. If you'd like to see my video titled Elegoo Centauri Carbon Printer, Better Value Than Bambu Lab P1S, that link is here. If you'd like to see my video titled Anycubic Kobra S1 Printer, Better Value Than Bambu Lab P1S, that link is here. Thanks for watching. Bye!